Hello everyone, I am Sanjog Dongol, a student from Softwareika College, linked with Coventry University. My IDs are 230562 at Softwareika and 148252228 at Coventry. Today I am here to talk about my Viva report for the Information Retrieval course. In this course, I have learned a lot about finding and organizing information effectively. It has been a journey of discovery, and I have gained valuable skills that will help me in my future career. My Viva report will show you what I have learned and how I have applied it. I'm excited to share my work with you and hear your advice. Thank you for giving me this opportunity. Our first task is given to develop a search engine. This vertical search engine operates similarly to Google Scholar, but focuses on retrieving publications authored by RCHL members. I have used web crawler and automated scheduling. The system fetches data from web page, updating its index weekly. Users can easily search for documents using keywords with search results. Now let's explore how the code works. We have used Flex, a web framework in Python, along with HTML for the user interface. Flex helps us handle user requests and generate responses. With Python, we manage the backend logic here, making our application run smoothly. Together, these tools create a user-friendly experience. Let's see how it all comes together. Here we have imported the required libraries, flags, and request, push for indexing and storing. Then we assign a constant variable here for our base URL and storage to store our crawl data. Then we come to make a method to crawl and index. Then we fetch our base URL using our request library, and we use beautiful soup to parse the HTML. We define a schema that specifies the fields to be indexed, and fields may include the document type like title, authors, years, publication URL, and author profile URL. This step ensures consistency in how documents are indexed and searched. We create an index object using the defined schema. The index serves as the storage mechanism. We create an writer object to add documents to the text. After that, we iterate through the documents obtained from the crawler. We extract title, author tags, we extract year, publication URL. For each document, extract relevant information, add it to the index using the defined schema. Then we add documents to the index. So under the hood, our host library optimizes the index. It merges smaller index segments into the larger ones and remove the unused terms, optimizing data structure for faster access. So hoods provide methods for efficiently updating the index without rebuilding it from scratch. Finally, we make a search method for query processing. Users can query it to retrieve relevant documents. Queries can be constructed using Whois query parser, which supports various search operators and syntax. The index efficiently retrieves matching documents based on the query criteria. Then finally, present the search results to users in a meaningful way in JSON format. We can run our app here. This is our simple UI where we can search our document using the words National Cycling Award. If we search this, let's search another word. We can go from this URL to this link. So here we see the accuracy and the speed of our application. That's all for this first task. Now let's move ahead to the next task. First, we have gathered a diverse set of documents from various categories like sports, business, and education. Next, we have employed a standard clustering method k-means to group these documents based on their similarities. Finally, we will demonstrate the system's effectiveness by assigning new documents to existing clusters. Here we are importing libraries Panda, sklearn, matplotlib, and NumPy. Then we load our data. Here we have a CSV file, news article categories, and if we see here, we read CSV with the help of Panda library, and we use only title and category column. Then we count our original data set. We find that we have these categories and we are going to use only three of them: sports, business, and education. We have to filter the data to get only three from them, make a loop here. So we get only three from them, and we have 501 documents in sports category, 501 documents in business category, and in education we have 490. We have plotted a pie chart to show the volume of documents in each category. So here is 33%, 33.6, 32.8, 33.6. Then we have plot a important graph here. It is word cloud library. We are using word cloud library, and it shows the frequency of a word in k-means model. Who has the more frequency, it appears in large size. Vectorizing our text, we can see in 3D model too. Here let's test the single word first and then the long sentence. So I copied from sports and it is giving sports as a result. I am copying it from education and it is giving me education. Here you can see the same, and the category is the same: education, sports. As we wrap up this Viva session, I am grateful for the opportunity to showcase our work and discuss our methodology. I believe that the knowledge gained from this project will serve as a solid foundation for future in the field of information retrieval and machine learning. Thank you for your attention and valuable feedback throughout this process. I look forward to further discussion and collaboration in the exciting world of data science.